Sorry if I'm a little out of it today. Yeah. Huh? I don't think so. I got sick on like Friday night, and I intentionally didn't come, so. You know, it's like, well, like I'm already over the end of it. Usually you're only contagious at the beginning. So we've been talking, last week we talked about some common command line programs, and we very briefly introduced bash scripting. We talked briefly about how to start to do some of the if statements and whatnot. Let's do a little bit of a review on that before we get into the new material or extending that material. How do we start, or what's usually the first line of a bash script? It's going to go print something and come back. Happens all the time. What's the first line we use with the bash script? Does anyone remember? Pound exclamation in bash. Technically, this is just a comment because the pound here, the pound sign, this means comment. I know you can't read that because it's way up there, but that means comment. I just didn't want to write underneath it, so I lose extra space. So technically, this is just a comment. However, most shells will take a look at the first line, and if it says that, we'll interpret it as a bash file, depending upon how you execute it. Other alternatives for this would be what other shells you have. So for example, you could do bin sh if you're just using the regular sh shell, or you could use bin c shell, csh, or csh, yeah. Or you could use ksh, which is the click shell or whatever, tcsh, which is the tickle shell, etc., etc. That would be the first line of your script. Inside our script, how do we get the first command line argument to our script? I didn't explicitly say this last week. However, I did use it a couple of times. How do we use a variable, first of all? Let's say we have a variable. Let's say I wanted to get a variable name, have a variable that was called name. That was going to be the first command line argument. So like the first command line argument to the program would be the user's name. As an example, I wanted to say, for example, I would say name equal sign with no spaces there. How would I use that variable name later? So I would use $name. $name would then get the value of name. When you don't use the $, that sets the value of the variable. When you do the $sign with the variable name, it gets the value of the variable. To get the first command line argument, it's going to be a $sign something. So it's going to be like $1 is the first command line argument. What's the second command line argument? $2. What's the third? $3, right? Makes sense. $4 would be the fourth. $5 would be the fifth, so on and so forth. In bash scripting, or in shell scripting in general, you take your command line arguments and then you can reassign them to variables that make sense. So for example, what I'm doing here, if I did the following, the first command line argument is the what?
The name?
It's the name, right? What's the second command line argument?
Great.
Password, right? And how do I know this? And this, the way that I know this is that I have now commented or documented my code using my code. So later in my code, if I wanted to, for example, this would be terrible. Don't ever do this. Don't ever put passwords as a command line argument because then everybody can read it. It's called plain text. Don't do that. That's an example. The $2 is the password here. Now I know that pass is the password, not $2. So later in my script, if I have a complicated line that has a $2 here with some more stuff and a caret and some more stuff and a $1 and a $2 over here, right? Let's suppose I have a very long line or a very big part of my script in here. And I don't know what this other middle parts is. But do I remember what $2 is? What was it? It's the password. But what did you have to do? You have to remember that $2 is the password. Right? It's easier to do the following. $pass. What is that? That's the password. It's much simpler to do that. And just at the very beginning, just to do this inside your scripts. And so oftentimes in shell scripts that take command line arguments, you're going to have the very first section is just going to be taking the command line arguments $1, $2, $3, and renaming them to whatever the variable that's going to document the use is going to be. This is an example of what the kind of situation, because what is $1 and what is $2 again? Everybody has to go, oh, $1 is the name, $2 is the password. When you look at that, that's the name. Takes that extra split second between visualizing it and remembering what the link is. The other part is, let's suppose you have several, let's say you have 5 command line arguments, and then you have several other variables that you then, you have like $F and $T and some other variables that you're using as well. How many of those things can you juggle in your memory at once? Without good variable names, it's going to be difficult to do. So this is typically one of the first steps, is you have something like that. Last week, we wrote the echo program. And what did our echo program do? You remember? We also have the other program called PARGs. Does that help?
They told the information set. Files. Something.
So they both printed something. PARGs happen to print the command line arguments. Print the arguments was what the program was called. And our echo program just echoed whatever was in the command or the standard in to the standard out. That's what our program did. The standard, so when I go to standard, when I say standard echo program, the echo program that lives inside of bin echo doesn't do what our echo did. The bin echo program echoes the command line arguments to standard out. So for example, if I wanted to print the name and the password, I would do something like this. I would say echo $name, $pass. And so, and they would echo the command line arguments to standard out. So this echo command is going to print that to the terminal. So the echo command prints to standard out. Not what we did last week. Prints to standard out. These variable usages are replaced. They're actually string replacements prior to this command being run. To understand what that means, let's take a look at the following. So for example, if I wrote, actually before I write it, go ahead and take a sec, write a bash script that prints hello world. That's all it does. Take 10 seconds, write a bash script that prints hello world. How many lines does it take? 2 lines. The first line is the bin bash line. What's the second line? In this case, we have the double quotes. If you also use single quotes, so if your line was echo hello world, that would also work. It would also work if you did no single quotes or double quotes at all, simply because that's the way echo works. So just print all the command line arguments. Hello would be the first one, world would be the second one. All three of these are the same, or all three of those would be the same. In the instance, let's suppose now that we have this name equals $1 in here. How do I change this echo hello world to say hello name instead of whatever the user's name was? I use $name, and where would I put it? Right after the hello. So instead of that world, we now have the $name inside there. Yes?
Are we supposed to be supposing that we're using the echo that we wrote?
No, we're using the echo that is written, the base one. We're going to throw that echo that we wrote last week out the window because when I thought about it after I started, I was like, oh, well, we're backwards. So this is the echo that is built in. Both of these would be equivalent here. What is interesting about this, or the way that we use this? So within the double quotes. That's really one of the big powerful things about Bash. And something that we have to remember as well is this replacement here happens prior to the rest of the line. So it's not double. It's not that the $name is not inside of the double quotes. The $name is actually replaced prior to the double quotes being evaluated. So this entire line prior to execution gets rewritten as echo double quotes hello, whatever the user's name was. So that $name is replaced. It's a text replacement. You can also do it without any quotes, or single quotes or double quotes. That would also work. Any questions about those? That there? Okay. Let's suppose I have two programs. A program that takes a command line argument, and then a program that takes an argument or an input through standard in. So we'll have prog A and prog S. Prog A will be an arguments program. We'll take the argument through command line arguments. Prog S will be the command line, or we'll take it through the standard in. How do we get name into the command line argument program? So we have prog A and prog S. So for example, if I wanted to call prog A, how do I get name into prog A? Program. So what do the carrots do? It's a good idea. What do the carrots do? So this says standard out to file. Would that help us get the name into prog A? Not at all. But that's good. Good one. What's the left carrot do? File the standard in. Now, prog A takes its thing through the command line arguments because it's the A one. Does that help us get the name in there? No. So the carrots don't work. What's the other option besides the carrots that are coming?
Could I go with the standard out and then put the vertical
Pipe? Pipe? Yeah.
Pipe, yeah.
So what does pipe do? So let's talk about what pipe does. What does pipe do? Standard out to standard in, right? Do any three of these do anything with the command line arguments? And the answer is no. Unfortunately, they don't. Huh. What's the answer?
Google.
Huh?
Google it.
We could Google it. Prog8 takes command line arguments. That means that when we execute it, like we're executing, when I write this line right there, I'm executing prog8. That means that this part here is a command line argument. So whatever comes after it. So if I want name to go into the command line argument, I simply do $name. Right? Because this line, this prog8 $name, gets rewritten to the execution of prog-A and whatever they type there. So it's kind of that was kind of a trick question. I was asking you to do something that was pretty straightforward. You just do the $name. You don't have to do anything special. But we do have to do something special for our prog-S, which is the one that takes the standard in. So I want to execute prog-S. How do I execute prog-S? This is what we were saying before. With prog-S, we take the input through standard in. So we come over here and we look at that goes to standard out, so that happens. We have that one which takes the file to standard in, and we have standard out going into standard in. Which one of these would help us get name into standard in? Which one? The pipe would. So we know that to get to, we're going to have to pipe something, whatever this is over here, into our prog-S. What do we want to pipe into it? Echo. What does echo do for us? Echo is a program that takes a command line argument and puts it on standard out. So if you have a variable, for example, name, and you want to take that variable and put it into the standard in of a program, you need to have a program that will echo it out for you. Like so. So that's going to echo the name into prog-S. So. Questions about this? Yes?
I might cover this later with multiple standards.
So echo is going to take a single. So this is This is only going to take a single line, right? Let's suppose you want to have multiple lines, right? That means you have to have a source of multiple lines. Typically, echo is not going to give you a source of multiple lines. What is a common place to have multiple lines? Inside of a file. So let's suppose we have a program that's going to take multiple lines of input. Where do we want that input to come from? The answer is going to be a file. So if we have, let's say, program MS for multiple standard in, we would probably want to use a file to a standard in, like so. And we'd probably do something like this. Multiple standard in. And some file name, like so. And so that file name will be redirected to the standard in of that program. Multiple standard in. That's the most common ones. It's not the only way to do it, but that's the most common one.
And then it'd be like, for each line, do run off 1, 2, 3 standards.
Correct. Or multiple, depending upon how you might have, let's say you have 5 integers on each line, and in your scanf only read 1 integer at a time, it would read 5 per line, even if you have multiple lines. What is and so if we do this, right? What does that mean? Because you're right about something. What does this mean about this program and that file?
Can't have the same numbers of like standard ins to lines.
They have to have the same file format. And that's where we get the term file format, is we write programs that are made to read specific files or specific kinds of input. And if that input is not in the format that we're expecting, it's going to fail. And so we have to make sure that our files are in the correct format. That's why if you try to open Excel spreadsheet files in Notepad and change some characters, then reopen it in Excel, Excel's probably going to barf on it. It's one of the problems with it. You can't just open willy-nilly any file with any other kind without knowing the file format. Once you know the file format, then you can read that type of file. For example, web browsers can display multiple kinds of image files. But many of them, for a long time, could not display, if you're familiar with graphics, TIFF files, TIFF files. Modern browsers, I do believe, display TIFF files. But the reason why they didn't display TIFF files is they didn't know how to read the file format. And until somebody programmed the file format for TIFFs into the browsers couldn't display that file. I don't know, maybe they still can't. Whereas PNGs and GIFs and JPEGs are much more well understood or well used file formats. That's where we get the concept of file formats, is that if this program doesn't know how to read that file, we're going to be in trouble. That's part of assignment 3, actually, is file formats and files. Let's suppose, let me do this another way. I want to be able to capture the output of a program. How do I capture the output of a program? Sorry? So I can capture the output of a program using the right caret. So let's say we have an unknown program, so we run unknown. I can use a right caret to capture the standard out of that, and that's going to put it into what? Into a file, so let's call this foobar.txt. I have no idea if it's a text file or not, but could be. So in this program, unknown, we're going to pipe that unknown into foobar.txt. How do I then use that foobar.txt, or how do I then use that data with another program? So I can use a left caret. So I can have another program, and I could say left caret foobar.txt. So that would make the other program, other proc here, use foobar.txt as the standard in. What's the requirement that other program must have now? It can take the file format of foobar, can take it where? Through standard in. What if other program here doesn't take it through standard in? What if other program expects its input through the command line arguments? Would that work? That would not work. So this is not valid. So this would be other program. This would only be other program, for example, S for other program standard in. If I had another program A for arguments, how would I get, let's suppose we did unknown into foobar. How would I get foobar.txt as the command line arguments of another program? What do I need to do? So I couldn't use pipe because the pipe would still put it into the standard in. So one of the things I'm trying to do is I'm not trying to put it in the standard in anymore. I've already gotten it in the standard in. I need to put it to the command line arguments. If I have a command line argument program, that means I need a variable that I can then do a text replacement in a single line like this. That means that I know that I have to have my second line be something more like this, so like other prog command line argument. I have to have some variable name here. Let's say variable name, let's say file contents. How do I get the file contents into that variable? File contents. No. Cat. What does cat do? Cat. Oh, move it over to the right. Cat prints the contents of a file to standard out. Why did I write it over there to the right? Okay, close. Almost there. One more thing. Not the dollar sign. There is a way you can do it with a dollar sign, but we're not going to use that. The graves. So I'm going to do graves as that severe slash right there. They're not single quotes, which I'll try to draw vertically. Graves. What does the grave do? Whoever answered graves, because you're right. What does graves do?
It executes and then saves the output.
It captures the standard out and puts it into the variable, right? So do I have to do these? Do I have to do that instead? What if I just wanted to do this? What if I didn't need to do this one here? How can I rewrite this line up here to do the same thing? Without this intermediary file. Excuse me. Say that one more time. So, when we do the graves around the unknown executes. We take the standard out. Instead of redirecting it to a file, I redirect the standard out to this file contents variable. Then I can use this file contents variable down here as the command line. So now we have both ways. We have ways of executing the program, taking that execution, sticking that execution into a variable, and sticking it into a file. I can take the value of a variable, and I can either pass it as a command line argument, or I can pass it as a standard in. Either way. Because these are the primary ways that we do communication, we either communicate by putting information into standard in, or we put information into a command line argument. That's the way that we have all programs interact with each other. Okay. I'm getting tired. I have to stop early. Questions about this? No? Okay. So what are the programs that we know how to use, or that we talked about using last week? Go ahead. Awk. Send. What else? Netcat, cat. Talk about echo today. Cut,
Translate.
translate, ER. Any other ones? Change mode? Yeah. Okay. Let's write a script. So what I want you guys to do is I want you guys to write a script that will change the mode of every file. I want you to try this. It'll change the mode of every file in the directory to executable, or add the executable flag that has the bin bash as the inside, anywhere inside the file. It doesn't matter if it's the first line or otherwise. So see if you can write a script that will read all of the files in the current directory. You can change the mode of that file if it has a bin bash inside of it. There should be a question, and we talked about how to do part of this last week, but we didn't go into it very well. We'll do it. That's what we're going to do There should be a question about how to do one of these steps in particular. And I want you to try to do as much as possible, and then we'll fix that last step. Just write some pseudocode in there if you don't quite know how to do it. Does anyone have a question? Okay, so I'm going to claim that there's two steps. We have the first step, and we have the second step. What are those two steps? Well, so you said change the mode of all the files, right? Is that the first step or the second step? Second step. So this is going to be the change mode, chmod, all the files. Right? We might have multiple files. That's the idea. We might have 100 files. We might have one. We don't know how many files we have. What's the first step? Find all the files. So so those are the two steps, and we want to have. And this is probably the step that we're going to need help with the most. So, how are we going to? Let's just brainstorm a little bit. Prior to writing all the parts down. How are we going to do the first step? So we're going to grep for the first step, right? So we're going to grep. Grep will do all of the work for us. Does grep not do something that we needed to do? Or what might we also need to do?
We need to isolate the name of the file.
So if you have tried it already, one of the things I always forget this. Is that you'll realize all of a sudden that you get actually the file name and the line that is contained on it. We only want just the file name. Because if we're going to be doing the chmod, it doesn't matter what line it's on, we just want the file. And so we need to also separate file name and separate the file name. What are we separating the file name based on? The word form.
Are you talking about the
There we go. Based on the delimiter. So we're going to grep, and then we're going to separate the file based on the delimiter. That's the big concepts that we're going to do. So we know grep is going to find them all. Do we know what the program is going to be that's going to separate it based on a file delimiter? Anyone remember? Cut is what it's going to be. So we know the second part is going to be cut. Here, so we can do a cut. I haven't written any code yet, have I? No. So this step that I'm doing right now, this is programming. Everything, so this part over here is programming, this part over here is programming. The part that we're going to do over here is coding. Because this step here is independent of language. I could say, hey, we want to find all the files. It doesn't matter if we're programming in Java, C, Bash, C#, Maybe name it. That's our first step. Our second step is going to chmod all the files and change all the files. Doesn't matter what language I'm using. Then over here, I'm figuring out what language tools do I want to use to accomplish this task. So for example, if I wasn't doing this in Bash here, let's suppose I was doing this in Java. How would I find all the files in Java? What things would I need? I would have to use a scanner. Now, a scanner reads standard in, right? Or not necessarily even standard, it reads files. So what would I use the scanner for? Yeah, I'm not saying you're wrong. You're correct, but I just have to figure out what I'm using it for. I have to use the scanner to find this string up there. So I have to use the scanner such that I can go through all the different lines to find that line. I'm going to use a scanner. What do I have to use a scanner on top of? What? A file stream. That file stream has to come from a directory reader, because that directory is going to have to tell us where all the files are. Right? So I can do the same process of being able to find all the files by breaking the steps down in Java. The same thing should be true for any language that you're going to be programming in. Now, if I said, hey, how do we do this in C? You should be like, oh, I don't know how to do that in C. That's okay. You might know that we're going to use fprintf, or not fprintf, fscanf to read the files for the same way we're reading the scanner. We have to know that we're going to use files and file pointers, and so you might have to learn a little bit about that. But then you have, how do I read things and how to use a directory scanner in C or something like that? Well, I don't know how to do that. You have to research that. And so the reason why I say this step is programming is because this is the step where you type all this stuff in Google to start with. For example, if I ask you to solve a problem, like if I asked you to solve this big problem in Java, you have no idea where to start. And you started with Java. How do I chmod all the files in a directory using Java? If that's what you Google, your results are probably not going to be very good, because Java isn't used for that purpose. If, however, you said, how do I read all of the files in a directory in Java, you will probably actually get much better results. How do I read an entire file for a specific string in Java will also give you better results. And that's the step of programming. And that's where we're breaking the problem down. No code. All I'm doing is breaking the problem down based upon what I'm trying to do. That's how I program. Okay, so let's program this second step. How do I do this second step here? I'm going to chmod all the files. I know I'm going to have to use chmod. What programming concept, independent of language, allows us to go through a bunch of stuff? A loop of some kind. So I know I'm going to have a loop around that chmod. So I can even do this, loop around that chmod. This is pseudocode here. This is the step of pseudocoding stuff out. And then I can start to get more and more specific. And then, now that I know that I'm trying to do this stuff, I can get another step more specific. Loop through a set of things in Bash. Like, oh, shows me how to do that. And the answer for this step here is I'm going to do it. Let me rewrite that variable name so it's easier to read. Okay. It says for fn in $set of files do done. What's this $set of files? It's a variable. What's it going to contain? A set of files. Excellent, right? This is where code should document what it's doing. What do you think fn stands for? So this is where fn is confusing. Function is not correct. What's another idea? It could be file name in this case here. And so if you start seeing that fn and you're like, I don't know what fn means, that means that my variable name isn't very good. So I should really make this something more like this. For file name, in set of files, do done. So for each file name in the set of files. I'm going to turn it back to fn simply because it's shorter. But I don't want to write a bunch. That's how we would do something like this in Bash. And I can learn, and by knowing what to search to do this specific case, loop through a set of files in Bash, I will find this solution. Because that's what I was doing. This is what will show up, something along these lines. I know that inside of this loop, I want to be doing this chmod, but I don't know exactly what this chmod is going to be doing yet. So let me just write a chmod here. And we'll replace this chmod, or we'll continue this chmod as we go on. Now, I don't want to search anymore on that. Let me see if I can figure this out before I start to Google how to finish that chmod there, or I have to get more information. Let's go back up here to this first section and read that. How do I link those two? How does that section and that section get linked? No.
You take the output, you take graph, type it into cut, and then with graves, put it into variable set file.
There we go. So you are correct about the whole step. The question I asked though is how do I connect the first section and the second section? And the answer is with the variable set of files. That's how I'm connecting the two of them. You're right. And so the rest of it is correct as well. But this set of files here is the connection between the two of these. And so when I'm saying, hey, I want to get information from here to here, I'm going to be putting it through a set of files. That tells me that in my first section up here, I'm going to have a section, my last line or one of my later lines should be something along the lines of set of files equals something. And the thing that it equals will be a grave, because I want to be capturing the output of something into it. Exactly. And so I know a bunch about the rest of this. I know a bunch about this without doing any more programming. Right? Without doing any more contemplation of how do I solve this problem. All I'm doing is I'm connecting sets, or not sets, connecting sections. And so I know that the grave is going to be there, and I have an equal sign and the variable. Now I can think about what I want to put in there. And I know that what I want to put in there is I want to put, I know that I have two steps here. I have the grep and the cut. I know that the output of this guy, we're breaking into two lines before we do a single line section. The output of this, or the output of the cut is going to be the part that goes in here. Cut, something, something, something. Do that in purple. I want to cut something with my graves, right inside of my graves. I don't quite remember how to do my cut or to finish my cut, so I'm going to leave it blank for right now. But I do have to realize that the cut is going to be cutting something with something else, correct? And what does cut do again? How do I make a cut work? I don't know exactly, so I'm going to leave it blank for now. We'll figure that out in a second. We're going to realize that this is actually technically incorrect. We'll figure out how to complete it. The first step is I know I need to grep something. I need to grep something. And what am I grepping for? The bin bash up here. I'm going to put that bin bash in double quotes here. What does putting the double quotes do for me there? It's always the first. I'm just saying this is one command line argument. Obviously, if I did put the double quotes here, the bash would still read that as a single command line argument. Really, what the double quotes are doing here is it's telling me that it's a single command line argument. Saying all of this is one section. Do I need to escape any of those things? Don't know. Probably not. If I did need to escape them, I could run them individually on the command line by themselves, and if it didn't work, I could figure out which ones I need to escape, then I can escape them individually. Actually, I don't need to escape any of those because they're not getting the backslash. All right, so I'm going to grep that. What do I want to grep that on? Current directory, so I can do that with just a dot and a sum. It's a grep on the current directory, or I can use a dollar, an asterisk to say grep all files. Grep on all the files. Where is grep going to put the output? On standard out. So let's think about this. Where does cut want its input from? The answer is standard in. So if I want grep standard out to go to cut standard in, I want to pipe the two of them together. So I know that I want to take the type of this guy, and I want to put it into that cut there. And this is where we get that. Okay, let's do it that way. So now I can see that if I want to take that and pipe it into that, so I know that I want to put this guy over here. Really, I want it to be around here. Like so. Yes?
Do we also make directory recursive?
So I said current directory, not recursive. Just the current directory. We could make it recursive with a dash on. So if I wanted to make grep recursive to do all of the files in all the directories, that you put a dash R right there, and that would make it recursive inside of all the files inside of all the folders. So now I have the grep with what I want, where I want it, being piped into the cut command, but I don't know the cut command quite yet. And I know that that's going to go to my set of files, and I've already Googled how to do this for loop like so, and I know that I'm going to do a chmod here in a second. Do that chmod last. Prior to doing the chmod, what would I now look for in Google for that cut command? The output from this is going to look something like, the output from the grep is going to look something like this. And there's just a number of these lines that are like this. It looks something along these lines. Where this first section here is the file name and path. The second section is extra information. How do I know that actually, first of all? Because I printed it out. Because what I did is I came over here and I ran this. I ran that grep command independent of my script. I said, oh, hey, that's what it prints out. If that's what it prints out, now I know how to use that cut. So what am I looking for? Right. So I can search on Google how to trim or how to get the first section, this first section after delimiter using cut, or how to trim using cut the first column, or et cetera, et cetera. I look for what I'm doing is I'm executing the command. I know the command that I want to use, or I think I want to use. I Google some information about that, and then I learn. And then what I get to do is I get to learn. I learn using the Google what I want to do, and I'm not. Then I get to Google what I think I want to do. This is that step there between going from the program to the actual line of code. One of the things that I might find is that cut isn't the right answer. For example, let's suppose I try to use translate. I try to use tr before. I say, hey, tr, you get the first section after a delimiter. And somebody goes, why are you trying to use tr? Why don't you use cut? Or why don't you use off? Or why don't you use? And then they demonstrate a command for you to use, and you can search and you can Google about things. In this case here, cut will work for us. And we'll find that cut will work with the following. We can use the dash D for the delimiter. Dash D, and we'll use the colon as our delimiter here because it's the delimiter between the sections. Correct? We also know that cut uses the dash F and then the number for which field it holds. That's what the F stands for, which field. That's the word I should have used. So we know that grep outputs this with the number of fields based upon our colon as our delimiter. We know that cut allows us to separate them based on the delimiter with the separate number of fields. The dash F1 will tell us to get the first field. And then it's going to output that back out to standard out. And then it's going to be saved using the graves into the set of files. Then, this section here, this for loop, allows us to iterate through each one of these files. What variable in the second section is going to take on the value of each of those file names? Fn is going to do it, this one right here. So how do I chmod Fn? The $Fn. Does anyone remember how to make his file executable? So, plus x. If I did a minus x, that would remove executable. Plus x adds executable. Plus x. Yeah. So this is the process of programming. Yes?
For like instead for you here, what if we just want to do here?
For the user X, yeah, that'd be fine too. So when she's talking, she was asking about some Unix and Linux specific stuff, user groups and all, everyone. That's what it is. Whether or not everybody can observers is the one, right? So, whether or not who can execute it. If you just make yourself executable on things, that's the most straightforward security-wise. And you can add things inside of there. U plus X, I believe, means yourself can execute those. That's the safe way. Any other questions? Yes?
Does it grade in after the
Yes. And so really, this would all be on a single line. I just ran out of whiteboard space. So we put this all on a single line. So there's an end after the cut. This is programming. These steps here are programming. These steps here are programming. This is not programming. This is just code. The hardest step, really, or usually the hardest step, is getting people to understand that breaking a problem down into these big steps first is what we want to be able to do. And so hopefully by the time, after you finish 107 and 108, you've got to a point where you're like, okay, here's the broad problems that we can solve with programming. For example, finding files and going through a list of files. Then I know that there's independent or smaller independent components that can be built together to make those sections happen, that large, broad concept. And then there's syntax for a particular language. Some languages are much more forgiving than others. For example, when we start programming in Lua, the syntax in Lua is much more forgiving than the syntax in any other language you can program. Lua doesn't care about a lot of things. Lua, if you want to use semicolons, go and use semicolons. If you don't want to use semicolons, you don't have to. For example, though, in Bash, if you don't have the, if you put an extra space there, Bash is like, no, that's no longer variable. We're done. But Bash is very particular about the way its language is used. The syntax is very unforgiving. And so when people talk about, I like programming in some languages where I don't like programming in others, typically there's two parts that they're discussing. When people say I don't like programming in Bash, what they're talking about is they're saying that Bash is so finicky or so fickle about its spacing and about its syntax that it's difficult to use. When people say they like using Python, typically they're not talking about the syntax because Python is relatively forgiving in the syntax. What people are talking about is the expressiveness of the language. So for example, Bash is very expressive, where C and Java are not. As an example, to talk about that is, how would you do this section, this first line right now that I have right here in Java, how many lines of code would that take? Just I don't know, ham-fisted guess of 150 lines of code, right? How many bugs would you have in that 150 lines of code? Way 150, right? One per line at least. Java's not very expressive. Whereas Bash, I can express many high-level concepts in a very short period of time. This also means that I have to be able to think in many high-level concepts in a very short period of time. For example, I have to realize that grep is going to be looking inside of all my files, particularly if I have the -r is going to be looking in cursive directly. I'm going to be doing this guy here. Well, maybe I have to worry about the fact that that pound sign might be a regular expression. I have to worry about escaping the regular expression if I don't want to do that. I have to know what the dot means. The dot means the current directory. All of these things are important. Whereas if you're programming it in Java, each one of those concepts is going to have a very specific line or set of lines to express that one concept. For example, the current directory is like 4 lines of code. A regular expression, searching for a regular expression inside of a string is like 3 lines of code in Java. And you have to explicitly say what you're saying. Expressiveness versus syntax. Java is much more forgiving in syntax, much less expressive. Bash is very expressive. Okay. All right. I'm going to post the assignment on Blackboard tonight when I get home. The assignment does contain the idea of breaking into, breaking into another user account or another server or something like that. The techniques that you're going to be using have been in the past used to break into other servers. Don't do it. Don't use it to do that. If, however, you do find a server that is set up like such, that the same methods are used, you should probably tell the person who runs the server that it's vulnerable. Many of the concepts, when hopefully this will drive home, if you're not familiar with password security, if you're not familiar with, don't save your passwords on your computer anywhere. You say, nah, my person, whatever, nobody will know, nobody will, not safe, don't do it. Hopefully this assignment will demonstrate to you how vulnerable certain things are. You say, hey, you know what, I use the same password for a bunch of shit. No, it doesn't matter if one of my accounts gets lost because I don't care anything about that account being lost. Well, this will demonstrate how fast, if one password is lost, everything you own can be lost, essentially, or stolen. Because that's what we're going to be doing. We're going to be exploiting. We're going to be exploiting the weaknesses that people commonly use in systems. And it's good. And really, what you're going to be doing is you're going to manually do it using manual command line tools. You're exploiting the weakest systems possible. After you've manually done this once, you're then going to automate the process. Where if you, for example, if you knew that a system ran this way, or what it was, you could then automate the process to get anything from anybody, if that was the way that the system worked. Fortunately, none of the systems that we use on campus work this way anymore. So, as far as I know. But do know that the way that the scenario is likely, if not common, much more common than it should be. If you've ever found yourself at work, if you have a job, you have a login at work, and that login has the same password as any other password, you'll find out that you're SOL for a lot of stuff, particularly if you use it multiple places. But I am not going to be able to do any more because my head hurts and I'm ready to pass out. You are allowed to change your master password. If you don't know how to change your master password, the PASSWD command, password program, that's the password program, will allow you to change your password on your mass account. I suggest that you change your password on your mass account. It's not, whatever. But I have, for the autograder to work and for for me to be able to grade your assignments, I have my public SSH key already in your authorized keys folder or file. Do not delete your authorized key file. If you have removed it, I will go back and add it again because I have another way into your accounts anyways. But just leave it in there, and I don't care what your password is.
Increasing the font size again? I know you said it, but I need it right now.
Oh, for
Font size.
so if you're using putty, it's one of the options in appearance. If you're using X132, it's on the fonts in one of the